we've got another shot. This would be a cool shot to see the rocket go through once it kind of clears the strong back and clears the tower, basically, is what that would be.
Again?
Then we've got another shot. This isn't the one that's tracking. Is it, Andrew? Oh, this one is. That's a close tracking camera. That's a very close tracking camera. That camera will actually move with the rocket and track it as it begins to ascend off the pad. So that will be one that'll be really fun to check in on soon after launch. All right, next shot, Andrew. This is also another tracking asset. This one's actually infrared, which is very necessary at Vandenberg because normally these rockets end up flying straight into clouds or through fog and you can't see anything. And tracking assets are actually valuable for the launch provider and for the range to make sure there aren't the vehicle's not having an anomaly. And if the vehicle does have an anomaly, it's good data to be able to look back on and see if there's, all the data, the better. And here is just another infrared camera as well. So again, basically right back into having the ability to fly through clouds and all that stuff. This one's actually really cool. It's from like very far away on a separate mountain, and it's a little bit shaky, but it's also because it's very, very zoomed in on a long telephoto lens to be able to get that shot. That is also a really cool.
We're about 30 minutes out, Demon
Hat. So from the range assets. Now next up we have a camera that I cannot wait. I cannot believe we actually talked them into this. And for those of you that watched, I actually launched or streamed when China sent a rover to Mars. We stumbled upon Trench Cam, and ever since then, I have dreamed of this day when we can officially provide for you guys Trench Cam. So how awesome is that? This is full blown Trench Cam City. Like this is an actual camera right there. Trench Cam, I can't believe it. We got access to Trench Cam. But believe it or not, Firefly, again, I'm not trying to butter their biscuits too much here, guys, but the level of transparency this company has had has just been amazing. They basically just keep saying, sure, sounds good to us. You just do your thing. We were asking if there's a camera that could show engine gimbaling, and we can't show this very long. We're going to show you a real quick little preview, but then we have to turn it off. We have engine cam. We have flamey end cam. That's all we're going to show you for now, but we will be able to show you that at ignition, which, come on. If that's not the coolest thing, what? Yeah, so that's awesome. Trench Cam, and this is blowing me away. We actually had an official pointy end up, flamey end down check. We have Trench Cam, and they even took it another level up and took it into engine cam, into flamey cam. So flamey end cam, yeah, unbelievable. So yeah, so that gets us into waiting here. We basically have 9 minutes where I'm going to answer a couple of your guys' questions until we wait to hear about the terminal count. So
restreaming this content is just fine. You can, with the Firefly cast, Tim said it was okay, dudes. I know him, Astro. Yeah, I know him. We've met before. Tim's a good dude. I like him. He does a good job, really. Like, you know how I have beef with people that spread just crap takes about all the time? Tim is not one of those people. Tim is the opposite of that. So, yeah, I have no problem. And I'm happy that Firefly and him are letting everybody restream it. Guys, that's so that right there is Slick 2. That's Slick 2 at Vandenberg Air Force Base. That's a shot of Firefly's rocket called Firefly Alpha. This is the first flight of this rocket. It's never flown before. Firefly is a newer company. They are another small satellite launcher startup, but Firefly's more than that. What they're trying to do is they're trying to work on, I mean, obviously they have their own small sat launcher, the Firefly Alpha, which is what you see right there. But Firefly is trying to, aside from just doing rocket launches, they're trying, oh, they had a vent right there. They're trying to standardize like the components and become a parts supplier for rocket components to make building rocket launchers and rockets a lot easier. So it's not just the they are in on all kinds of stuff. Firefly has diversified their aerospace portfolio pretty hard. They work on trying to mass produce supplied components like valves, pipes, stuff like that, electrical wiring for rockets. They're trying to become a parts supplier, like McMaster Carr for rockets. I mean, McMaster Carr already is McMaster Carr for rockets, but whatever. Firefly's been around for a good while, but anyway, back to the rocket. That's their kind of spiel into the game here, into the small sat game. It's not just launching payloads, but it's also working on the supplies for the payloads, right? Yeah, no, Hazanko, I understand the reason. Yeah, absolutely. Don't they have plans to do orbital manufacturing as well? Kind of. They're working in They have plans with hypersonics and GravCirc. They're involved in the CLIPS program, Commercial Lunar Payload Services. They have a lander that's entered into the Commercial Lunar Payload Services, if I'm remembering correctly. So they want to try to be the Mopar of aerospace. Yeah, that's a good way to say it. Or FOMOCO, or like AC Delco. Like they want to be a part supplier, but also launch their own rockets. The Firefly, the Alpha rocket right there, is a 2-stage Carolox rocket, and it has 4 Reaver engines in the first stage. Reavers are, I think those. I actually have to look. There's so many small sat launchers. There's so many small sat launchers around that I forget which engines are on which. I know these are Reaver engines, but let's see. So it has 4 Reaver engines, and each one of them makes about 730 kilonewtons of thrust. That's 165,000 pounds of thrust at a specific impulse of 295. Not bad. So those Reaver engines are the tap-off cycle. It's a tap-off cycle where basically the actuation for the turbopumps is driven by it's tapped off of the combustion chamber pressure. There's not many engines that use tap-off cycles out there. So basically, with a rocket engine, you have a turbine wheel, right? And then the turbine wheel is attached to a liquid impeller, which moves the fuel around. And for a turbine wheel to move, you have to blow on it to get it to move. So what they do is, the combustion chamber has a little pipe coming out the side. Most of the combustion chamber pressure goes out the bottom of the Reaver engine, right? But they have a little tap off that goes to the side, and that leads to the turbine wheel. So some of that combustion chamber pressure is tapped off from the main combustion chamber to spin the turbopumps. Just watch the Astra rocket take off sideways. Yeah, it was pretty cool. The Astra rocket was fun. And then in the second stage, it has a Lightning 1 Carolox motor delivering 70 kilonewtons of thrust. Okay. Cool. 70 kilonewtons of thrust at 322 seconds specific impulse. That's not bad. What is PFUD? Probably pre-flight something or other. Oh, pointy end up, fiery end down. Nice. How do they start that? They could use a bunch of different things, Finn. It could just be a starter motor. They could have an electric motor attached to the turbine. Start it like a car. That's unlikely, though. It's probably too heavy. My guess is they're using T-tab or something. Triethyl aluminum and triethyl boron, which is pyrophoric ignition. So basically, if you thermally chill down the engines, right, with liquid oxygen and kerosene, right, once you shoot the pyrophoric igniters into the liquid oxygen, it explodes, and that it'll flash a green flame. I do not know if the Reaver engines use those. They might. They said ground pumped nitrogen. Okay, so it's GSE. It's a GSE starter. So they're going to take nitrogen, and they're going to shoot nitrogen into that turbine to get it to spin, and then once the engines are up, the tap-off cycle will take over. How tall is Alpha? Alpha is 29 meters tall. That's about 100 feet. This is not a small rocket, guys. Astra's rocket, for instance, the other day, is probably about this tall, comparatively. Rocket Lab with Electron's probably about this tall. Now, this thing is about as tall, maybe a little bit shorter than a Vega rocket, a European Space Agency's Vega. It's a big rocket. Is this a brand new one? Yeah. If us, yeah. This is a new one. Brand spanking new. This is the first flight, dude. That's serial number 1 right there. And compared to a Falcon 9, about half the size, Squall. Yeah, it's about half the size of an Atlas or a Falcon. It's not small, but it's not big either. It's a light to medium duty rocket. So somewhere in the ballpark of like the ESA's Vega rocket. Somewhere in there. The press kit says T-tab. Yeah. It does. Oh, okay. Cool. Could you link me the press kit, Smarks? That could help me. Something fierce right here. So this is the Dream mission, Firefly's first mission. There are several customers from all around the world. See below for a full list. The rocket is the Alpha rocket, Slick 2. Payload mass is 200 pounds, 92 kilos. 300-kilometer low Earth orbit at 137 degrees inclined. So that's a retrograde orbit. Almost, little more than 137 degrees inclined. Huh. Nice. Yeah, fully expendable. First stage will land in the Pacific Ocean. You're not getting the fairings. Cool. Oh, there's a bunch of stuff on this. Okay. The go no go poll. All right.
Episode of
Let's
Road
turn
to
Timmy
Mars
back
from
on
Cosmic
here.
Perspective because it was incredible.
Firefly is the
those two
company,
work on
Alpha is the
something
rocket.
so
This is their
hard and
first
put
flight.
so much effort into their
Inaugural
videos.
flight.
It's just unheard of. Their way of storytelling is amazing. If you guys aren't familiar, obviously
Hit live.
their images, and it's
Okay.
just been an awesome partnership. So I'm so proud of the work they do, and that made me teary-eyed. Now give us a second here. I believe
Timmy's
we
just
may or
doing
may
his
not
thing up there.
be trying to refresh the camera feeds here, so hopefully we can try to eke out a little bit of a little less lag here for you guys. But we will get them back in just a second while
Not
we
a
continue
flamethrower
to
over
answer
there.
questions. So this is a great question from Razenbot. Many light launchers now, do you think they will all find a place on the launch market? That's actually kind of the ultimate question to me as an aerospace fan is there are a lot. I mean, I did a video about the small sat launchers that are kind of coming online right now, comparing some of the ones that are getting really, really close to flying. And Firefly obviously was in that. And I kind of said at the end of the video, I personally believe, if you can get a rocket on the pad and get launching and attempting to launch this
That's
year, you're
not me
probably on
skipping,
track
by the way.
for, survivability. But if your first rocket for small sat launch is 3, 5,
Do you
10
know where they
years
make
away,
the Alpha? California.
you're probably going to be just too late unless you do something totally groundbreaking, something completely different. But I think right now there is still some room for a little bit more. A couple more in the game. There's some really exciting rocket companies that are coming online here, I think like I said, I think if you have a rocket on the pad this year, you're looking pretty good. But the race is definitely on. So Firefly, if they, by the way, guys, I don't even know if I've said this. No.
I'm gonna go forward here.
Ever made it to orbit on its first attempt. The closest would probably be the Electron, Rocket Lab's Electron. The vehicle was actually good. They lost a ground track station that allowed them to continue tracking the rockets. They actually had to terminate their first launch, but they were close. They probably would have done it. Sans that. If Firefly happens to make it to orbit today, which again, remember, this is a test flight. This is the first launch of a brand new vehicle from a brand new company. If they get off the pad and start making some data, that's going to be progress for them, right? So we just want to cheer on any progress. But they're aiming for orbit. They're going for orbit fully. It's really impressive. You have to think about all the extra details, the guidance and telemetry. Okay. Poll is done. They are go for launch. That's awesome news. So we are now within terminal count. They're actually going for the beginning of their launch window for a new rocket company to be attempting their...
So at T-minus 20 minutes, you have the go, no go poll. That's basically where everybody goes around the horn and asks every person that's in charge of each individual system on the rocket. So like first stage, second stage, payload, ground service equipment, launch director, the range. Range are the people that control like the airspace around the launch sites. They're basically traffic control for the launch sites. They monitor the weather and obviously other rocket launches and space satellites that are flying over to make sure you have a nice clean window to go up. Basically, once they go around the horn and went through the go no go poll, that means everybody is, and they're proceeding with the count. That means everybody's good to go. Everything is good to go. Yeah, that's a good sign. And pirate ships. Yeah, no pirate ships. Yeah, it's about the same size as Vega. It's a light to medium duty rocket. It's not small, guys. It's not a small piece of equipment.
That made me think about, you know, I've been following this company for a while, but the first video that I ever saw of them...
Whatever, at least the pad's getting used, right?
About a year ago, I think. So maybe a little bit...
This was a Delta II launch site. This launch pad last launched something in 2018. ISAT 2 was the last flight to go out of here. But it's cool that, hey, you know what? It sucks that all the Delta II ground service infrastructure got scrapped because there was a lot of history there, because Delta II has a lot of history. However, I'm really just happy that they're freaking using it. I'd rather see a pad get used than abandoned. But anyway, let's see what Tom's up to.
We've been working tirelessly for the past few years to develop Alpha, a game-changing small satellite launch vehicle. And finally, our first launch is within sight. I'm proud to announce today that we're extending the capacity of our inaugural launch to you. That means we've reserved a spot on Alpha for you to send up whatever dream payload you can think of.
Don't say that to me,
We're calling the flight
Tom.
opportunity Dedicated Research and Education Accelerator Mission, or Dream Payload.
No, they've never launched anything before,
institutions, startup space entrepreneurs, or any other institution that has big space dreams to visit firefly.com and tell us about your dream space payload.
Should I go
tell them? On the website, you'll find all the details and specifications you need. We look forward to hearing from you as Firefly marches toward first flight, perhaps with your dream payload aboard.
Can they launch like a model car? Can we launch like a model Tesla Roadster into space? Can we do that?
So yeah, like I said, that happens to be the first video that I ever really caught of them, because they've actually been around for a while.
Can you imagine? Let's get a little model Tesla Roadster. Launch the model Tesla Roadster into space. Oh, that'd be awesome. How big would you say the Astro Rocket 3 is compared to it? About a third of the size. Astro Rocket 3 is over here. Even their extended version. This thing's 100 feet tall. Astro's rocket is 42 feet tall, so yeah, it's actually like 2/5 the size. So maybe like right where the E is. Astro's rocket is right here. It's a small rocket compared to this thing. This thing can haul, man.
Headquarters. Oh, also good news is we can actually listen in. We're going to pull up mission control audio. So if anything does come up over the comms, we will hear it live with you guys. So we'll all be informed together. Again, another transparency thing from Firefly. They're giving us a listen in to their mission control.
That'd be awesome.
Super cool. There is actually a few more videos. So
14 minutes.
As Tom walked away there, you did see that there's
14 minutes. RC, please contact the range and coordinate to begin recording RF tapes at T-minus 10 minutes.
Okay, they're going to turn on the flight instrumentation recorders.
Sweet. They're going for it. They're going for it. Crazy. So, okay.
Half the size.
There
Jack.
was a few
C-22?
more videos. Like I said, they have an awesome set of videos for their testing campaign. I actually wanted to run just a few of those testing videos for you guys because it's really cool.
Yeah, watch the Reaver engines. Ready? Pop.
So this that you'll see is a startup of 2 of their Reaver engines.
Let's see. Let's watch for the green flash. Yep. T-tab. You can see the black flames right coming out of the nozzle. That's a telltale sign of Keralox, so it's using kerosene. Very nice, eh? That's the upper stage engine. Oh, see the green flash?
Ground side separation.
Triethyl aluminum and triethyl boron. They're using pyrophoric igniter fluid. Like, bam. Does that rocket have grid fins? No. Alpha is a fully expendable vehicle. Same stuff the Saturn V? Yeah. Yeah, the Saturn V had black plumes for another reason, but they were a lot more pronounced, but that's because the F1 engines were regeneratively cooled. These ones, I don't think they're regeneratively cooled as much, but... Oh, we got a vent.
Starting to hear you.
We'll power off stage 1, stage 2 FTS.
Oh,
I just wanted to kind of point out a few things here about these videos. So this is at their site, which is about 45 or an hour northwest of Austin, Texas.
Oh, look at it
kind of in the
gimbal.
middle of Texas. But this is one of my favorites because it is the all-up test of their first stage boost.
What is pyrophoric? Pyrophoric means it reacts with oxygen. When T-Tab hits oxidizer, it explodes. It combusts.
Interesting about the way that their engines
Oh,
steer.
look at that.
They're actually only single-axis gimbals, but because you have 4 engines, 2 of them can go on one axis and 2 of them can go on the other axis.
I've heard
so
this
between
story
the 4
before.
engines, you actually have all 4 axes of control. Now, this is also a little clip from one of their. This is a short duration static fire they had at Vandenberg Air Force Base on the pad just about 2 weeks ago, I believe. They did some static fire testing.
I've
just thought
heard
this was
single
really
axis
cool,
gimbal
slow
and
motion
4x
video.
symmetry before.
You gotta love it. You will notice there's a bright green flash at the beginning of the burn, and that is using T-Teb. So they use the same igniter fuel that
Heard
the
this
Falcon
before.
9 uses to light up its engine. And that's triethyl aluminum, triethyl borine, which is a pyrophoric fluid. So as soon as
Stop
that
copying
comes
me.
in contact with liquid oxygen, it begins to combust. So it's a nice, simple ignition fluid. Super cool. So you actually could see that at the beginning of.
So, Christian, this is the first rocket I can think of with 4 engines or nozzles. No, Zenit has 4 nozzles, 1 engine. But I understand what you're saying. Are there any others like this? The RD-108, if you want to count that, I suppose. But no, I'm not sure. There might be more out there.
This is pretty wild. But yeah, real quick again, back to the engine gimbal. So I want to be able to use my hands to talk because that's how I normally talk. So basically, you have a set of engines that can gimbal this way, a set of engines that can gimbal this way, and between them you can do roll by having them all kind of gimbal opposite each other, or even
Hey,
a
Albert.
pair just gimbal opposite of each other.
It
You
wasn't
can go,
RD-107.
pitch or yaw just by using a set, and basically together to be able to do pitch or yaw with those 4 engines on just a single gimbal axis. That's pretty unique. But it's one of those kind of simple things, like why put 2-axis gimbals on every engine if you can get away with only using one? The best part is no part.
There you go, Doom.
So, super cool. Man, yeah, again, sorry, I'm still just like, I'm trying to catch up to the idea that this thing's
inside of
actually
10
gonna
minutes.
launch in T-minus 9 minutes and 40 seconds. All right, so, let's see. Yeah, so this was again from musical.
Timmy's doing a good job, man. He's doing a good job considering he's doing this by himself. Yeah, that's real good. He's really doing well.
Unbelievable. Super, super, super cool.
He sounds
So
nervous. Well, dude, okay, say this was reversed. I would be the same way. I would not be as cool as chill as I am right now. Someone told me that Saturn V's engines have black plumes because it was moving the fuel so freaking fast that's creating a vacuum or something there. That doesn't sound right. That doesn't make sense. When it's on the pad, it does that. There's a big black explosion, and then when the engines turn on, the vacuum sucks it down into the flame trench. But when the engines are actually going up, Flankin, there's a kind of a ring of soot around the engine exhaust. That's the regenerative cooling. They dump the gas turbine exhaust into the engine to keep the engines cool. It film cools the outside of the engine, or the inside of the nozzle. Hey, Switchio.
and began to actually ascend was really cool. I was cheering like crazy. I was doing the disbelief sign.
Tim is the official commentator. Yeah.
As it was power setting off. It was an incredible amount of guidance and control for that.
You should ask to host Relativity's first launch. Who says I haven't been asked? Just saying.
Copy. Go ahead and change that. Flight software takes care of it before we launch.
Maybe I haven't been asked by Relativity. Maybe I got asked by somebody else to do it.
Post-abort.
Whammy.
Cool. All right, let's keep going here. So yeah, again, this is from Alexander asking, how does retrograde orbit affect payload capabilities? So it can be, I think it's about, so
Press X to
normally if
doubt.
you're going from like
Ow.
a
Damn,
normal
No
prograde
faith.
orbit to say a polar orbit, you lose about 30% of your performance. I'm actually not sure. I think you still lose only about 30, maybe a little more when you go retrograde. I think you would actually lose a little bit more. But you, like I said, though, you do actually have to still negate your velocity, your rotational velocity.
600 meters a second. You need 600 meters a second more delta V if you're going to launch retrograde. That's like launching into a 180 degree inclined orbit. This one is going to, what was it, 170? That's almost completely equatorial retrograde, which is, or 137. 137, okay. Yeah. 137 degrees inclined. That's, so if the ISS is going this way, this orbit is going that way. It's going like, that's almost opposite of, that's the reciprocal of the ISS orbit, which means the orbit looks exactly the same, only one's going clockwise, the other one's going counterclockwise. For this type of orbit, you're not gonna need that full 600 meters a second because you're going diagonally to the way the Earth is spinning. So, but still, you're gonna need to pack a punch to put something into an orbit like this. Mainly because if you're spinning and you try to launch north or south, you have to negate that spinning. It's a pain in the butt. So polar orbits always require more delta V. That's why a lot of polar orbit launch sites, like Kodiak, for instance, are high. They're at high latitudes because the Earth isn't spinning as fast relatively up there.
Compare it here to the Falcon 9, you can see still how big a medium class rocket is. Quite a bit larger than these vehicles, but Firefly's Alpha is actually a very big small lift launch vehicle.
So there's Astra, Rocket 3, there's Electron, and then there was ABL, Relativity, Firefly, and then Falcon 9. No, this thing's bigger than Electron. It's a big rocket, Flykin, but it's about as big as a small sat launcher is going to be. Why do you think they are doing this? To make money. Yeah, that's probably. Also, launching things into space is cool. I mean, and if you can make money off of that, that would be really good. Why did they pick such a challenging orbit for their first launch? Mission confidence? Team, we're almost inside of 5 minutes. The strong back is retracting. Okay. Let's see what we got here.
No-go at this time will be an automatic abort. Again, at the T-minus 2-minute call, any no-go will be an
5 minutes out.
In work.
Like, Builder, I don't
So that was
understand what else you
so-
want to ask.
Minus
Like,
5
what do you
minutes,
mean?
strong back is secured in its launch position.
This is live tech. Yep. Well, now it is.
That is awesome. That's a good sign that things are moving.
Here, I'm gonna give us a little bit of a fast forward here. Prepare to fast forward. Fast forward. Fast forwarding, sir.
For a first launch to... Wow.
So the strong
I
back
don't
is
even-
backed off.
Yeah. I don't even know how they're doing this. So the next thing we're going to be seeing here in just a couple minutes, we might hear the call out for it actually any second here.
Anything special with Firefly?
Will be that the flight
they're
termination
about
system
to try
is
and launch
armed.
something into space.
And
Jackie,
actually, I
that's
think
pretty
that
cool.
call out is going to be around T-minus
Last,
4
please.
minutes. We should hear that on the net. And that's going to be the system that if the vehicle were to happen to have an anomaly and start to stray off course, they have the ability to
happens all the
terminate the
time,
rocket
Flight.
in flight, which is a good thing, you know, because they're
More
obviously...
often
LC, DCC, MCD1. We're about 1 minute to close on the LCCs for T-minus 2.
Copy. T-minus 4 minutes. FTS, please confirm FTRs are active and range is transmitting check channel 4.
FTS
Flight.
confirms that FTRs are active and range is transmitting check channel 4.
FTRs are flight,
Note, the ARM
flight
Enable 2
telemetry
command must be
recorders.
received by the ESAD within 30 seconds of receiving the ARM Enable 1 command. FTS, send ARM Enable
Flight
1
termination
command to all
system.
ESADs.
ARM Enable 1 command being sent in 3, 2, 1. Mark.
FTS, send ARM Enable 2 command to all ESADs.
ARM Enable 2 command being sent in 3, 2, 1. Mark.
FTS, confirm when all ESADs are enabled.
All ESADs are armed.
FTS is armed.
Well, Well, they did
All
more.
right, we can check that.
They did more than just put on the FTS. They turned on the flight telemetry recorders, which are basically a hard drive that's recording all the sensor information from the rockets. They also armed the flight termination system. FTS is basically a brick of C4 that's attached to the side of the rocket that'll blow it up if it goes where they don't want it to go. It's more like det cord, less like C4, but that's more or less the gist of it. They have det cord that goes down the side of the rocket, and they ignite the det cord, and it unzips the rocket, causing it to explode.
They'll do the go for launch at T-minus 2 minutes. So we'll
FTRs are not necessarily a black box because you don't get the black box
still
back.
good to go. That's kind of the final thing.
It records.
From here.
But yeah, it records and transmits the telemetry.
LCC on CD1. T-minus 2 minutes. Let's go.
Okay.
Go and throttle up.
I think that was go for launch
Those
already.
events.
That was...
And our Wood 22-month resub. Thanks, man. Awoken time, by the way, if they launch on the first try, I'll be pretty impressed. I don't think anybody's ever
T-minus 2
done it.
minutes. CE has performed the final check.
Okay, 1 minute 50. Let's do this. Hey, don't you dare.
Yes, is armed.
To autonomous mode at T-minus 30 seconds. To
We'll
stop
go.
the count, operators declare abort, abort, abort on CD1 and VC will abort the auto.
I don't know what that was. Okay, we're live as it can be. Alright. 50 seconds. They're
So they will begin engine ignition at T-minus just about 2 seconds. So
Can you please do this thing?
you'll see the green flash around then. And our clock might be a tiny bit off. We apologize for that if it is within a couple seconds,
low
but it's
resolution.
good enough for now.
Here you go. I'll put it back to 1080p so you guys can, so it can
30 seconds.
buffer right when it goes to launch. Watch.
Autonomous.
Okay.
RC give the final 10-second countdown on the net with positive calls.
Abort. Which we've aborted.
No good. They called an abort.
I think they're going.
Confirm there are no fires on the video.
See no fires on the video?
GC close world purges.
Bring-
Was that an abort? That was an
VC
abort.
confirm the following 3 valves are closed.
World bridge
Okay,
closed.
did-
3 valves are closed.
Confirm helium bubble
Abort.
is active.
Filling bubbles active.
Confirm S1 fuel tank is maintaining between 30 and 36 psia.
Maintaining pressure.
And all other tanks are vented.
Vented.
GC confirm the following T-type tank is vented.
Barely in the terminal count though.
Vented.
Confirm TBC tank is vented.
Venting.
Confirm spin system
Strong
is
backs
vented.
moving back into position. They're putting the rocket into a safe condition
VC
here.
verify the following. C Rio is in the release safe state.
Thanks for that, Azonka. You jinxed us.
Stand by 1. Spin system is vented. Cavity purges are active.
Thank you.
Now, just a little heads up, guys.
Cheerios in the safe state.
Friendly reminder
Please
here that
confirm
this
vehicle
vehicle, they do have a
FSW
4-hour
manual
launch
state
window, so
and
it's
the auto sequence.
not over yet. They had
Manual
something
state
similar
and auto
to this
sequence is complete.
when they did their static fire.
On
They actually were
CD1,
able
the
to
release
get 2
system
static
is now
fires in
safe.
during their
FTS
window.
confirmed
So,
the range were okay to disarm the power down the east side.
And work.
CRS
So we're gonna listen here.
57 pad area camera scan.
Yes, sir.
Well,
okay, so we're going to let them work the issue here, and we will await to hear from them on anything official if there's a chance.
all right. So they called an abort at T-minus 12 seconds. We got really close there. But okay, this is the first flight of a launch vehicle. Before you send this thing, you have to be absolutely sure there's no revert button. There's no do-over button. Once the umbilicals release, that's it. It's either get into space or fiery explosion. It's nothing in between. So they had a call at T-minus 12 for an abort. We didn't know the exact condition of abort, but all that blabber that you heard kind of after the abort was them putting the rocket into a safe condition. What that basically entails is taking certain systems on board the rocket and bringing them down from pressure, down from what's called flight pressure. What's flight pressure? What does that mean? The rocket has pressurized fuel tanks, so think like a soda can, right? When the fuel tanks go to when the rocket goes to launch, the fuel tanks are under pressure, and when they're under pressure, they're rock solid, and that helps the rocket kind of stay up. I mean, that it helps for structural integrity, but you want those things at flight pressure, but you don't want to keep them at flight pressure, obviously, for a long period of time. You only want them at that kind of pressure when the vehicle's going to launch. You don't really want to overpressurize the thing on the ground when that strongback is holding it up there too. So they started bringing systems down from flight pressure. They started depressurizing the liquid oxygen systems. I also heard them depressurize the thrust vector control systems, ground-side helium and nitrogen systems, and a couple of other things. Every rocket uses a couple of different things, a couple of different systems. A lot of them use nitrogen. A lot of them use like liquid helium or gaseous helium, basically. They use gaseous nitrogen, gaseous oxygen as the oxidizer, and kerosene for the propellant. But every rocket's a little bit different. They are basically, but I know what they were doing either way. They're putting the rocket back into a safe condition. Basically, what they're going to do is they're going to reset all the parameters to the conditions that the rocket was in at T-minus 20 minutes when they went for the go, no-go pull. They're going to reset everything and put it back into the startup state. So that's like safing the vehicle and then moving it back into the startup state. That's important to do because you basically don't want to put the rocket into what's called a failure mode. So if you just kind of leave the tanks pressurized and just cycle the count, you're not starting up in the same way that you got to that point, right? You're changing the launch parameters there by starting with the tanks pressurized at T-minus 20 minutes. So they brought the tanks down from flight pressure, right? And they're going to recycle it to the 20-minute mark, and then they're going to do that startup sequence over. However, it's important to understand what caused that abort and why the abort was called out. That's really important to understand. They're just going to show the other videos now. This is at Vandenberg, yes. I don't know if you'll be able to see it or not. I think you might be a little too far south. So the important thing to understand here, I mean, putting the rocket into the safe condition and getting it back to the T-minus 20 mark is important. But the biggest thing to understand here, what Firefly is going to try to do now is understand why. Why did it abort? What caused the abort? Why did it abort? Why did that happen? What was it doing? What was the sequence in which that abort scenario happened? That's what you got to understand. And this is why it's not just flipping it on and flipping it off and flipping it back on again, even though that sometimes does work. You have to figure out why that happened. And now it's a challenge against the clock here for the flight controllers. You got to figure out why the rocket aborted. Make sure that it wasn't a faulty sensor. Make sure it wasn't a false reading. You got to prove that it worked. Prove that the sensor is working correctly. Prove that the abort was real. The abort conditions were real. And then, it's a nice machine. That's a nice machine right there. And then recycle it, and, well, send it again and see if it does the same thing. But I mean, you got to be very careful. Figuring out why, though, is very, 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 very important. Per Big Papa Bear, they aborted for Scott. Okay? I hope Firefly Launch doesn't go exactly at 6 p.m. I have to be talking with my kids' teachers at that time. Also, enough of a delay for a twilight would be nice. Yeah. Okay. Yeah, I saw the Von Braun picture back there. Hey, SPAC.
There's big business to be had in space. Its estimates are on the order of $3.2 trillion in revenue by 2045, dwarfing any other business.
Final configuration. Operator, please check NPTO1.
Everyone at Firefly partially owns the company. So if you come to Firefly, you'll get equity. If we become wildly successful, everybody's going to get carried along, and you're going to do very well financially.
We're all owners of the company, so we're very motivated to get to launch.
So is it a co-op?
Which are going to be very comfortable.
Firefly is in a stronger position than it's ever been. We have an investor that's dedicated to pay the entire bill to get us to space. We do need some more people to help us get to the next level, but everything is in great shape right now at Firefly.
Where be the actual
People
countdown?
are the most important thing at Firefly.
But they're recycling, so they're
You know,
gonna
I'm
try
the
again.
CEO, but I'm out in the field working with the team on building the rocket engines. We're just a bunch of guys and gals trying to do something amazing. You won't find hierarchy here or a lot of roadblocks or bureaucracy.
Any crack?
The culture's very sort of family-like.
Test execution. RE. Verify blue lines are met. Operators stand by manual abort. Start camera recording and start auto sequence to provide a countdown.
Starting auto sequence. 5, 4, 3, 2, 1, 0.
Yeah, baby.
Firefly is great because you really feel like that you're putting your personal touch on this vehicle and on this system.
Just an amazing feeling.
Working here, you get an opportunity to work on something that's going to be very impactful, literally extending humanity's reach into the universe. And that's something, in addition to being economically secure, you can look back in your old age and be proud of and talk to your grandkids about.
You should apply, chat. You should apply, chat.
Right, and welcome back. Unfortunately, we don't have any new updates for you guys for a new T0 time, but that's okay because we can use this time to answer some of your guys' questions. Again, I will try to do everything in my power to get to as many of these questions as possible, but with the amount of people watching right now, we probably won't be able to keep up with everything. We definitely can't keep up with everything, but if we have good questions, they don't have to be super chats, guys. We put up lots of just regular chats for you guys. If it's a good question, we'll try to get to it. But yeah, I really enjoy the fact that we are able to just kind of hang out with you guys together. So it feels like we're all watching this together. So there was a chance for a little while. I was working on trying to do this in person. Unfortunately, I'm still recovering from COVID. I'm feeling 99% better, but energy swings are pretty massive still, even 3 or 4 weeks out later. So so that being said, we are doing this all remotely.
Fast forwarding, sir.
But there are probably some people out there in California that are buddied up, parked around Vandenberg Air Force Base. Sorry, not Air Force Base. So hopefully there's people that are there to watch it in person and watch this launch attempt today. So we're still hoping. Again, there is a 4-hour launch window here today. So there's a chance that this vehicle will recycle and they will be able to go for another attempt here within that 4-hour period. So we are officially only 10 minutes into the launch window, so they have plenty of time left. So, yeah, so just to confirm, I did see some people asking, yes, Firefly, the company, is in Texas, and they do their testing. Their headquarters is in Austin, but they are launching out of Vandenberg Space Force Base in California. So they're launching on the West Coast.
Nice, dude.
Yeah. So,
why not go plaid?
Let's see.
Plaid.
This is a good question from Crypto. Are there engineering cams so we can see the rocket after T plus like 100 seconds? We actually do have a onboard camera that we will be able to show.
There you go, Scott.
Once this vehicle leaves the pad. That is something we will be able to show for you guys. And the other fun thing about this too is, again, that we have the awesome tracking camera assets from Vandenberg Space Force Base. So we will have some of the best telescopes in the world pointing at this vehicle.
Firefly is working on a bunch of different type of stuff, Squish. Firefly's working on all the lunar landers, hypersonic aircraft. They have Firefly Alpha. They're working on standardization of rocket parts. There's a bunch of stuff. Like they even want to contract out the Reaver engines. Like Firefly is going for a type of business model where they'll basically sell you the parts wholesale. Like if you have the right credentials. They'll sell you the parts wholesale, and you can use them as a parts supplier. So they are planning mass production of those Reaver engines, from what I understand. It's actually. Who the hell is this?
would agree with that. Energy was incredible. Again, we will be talking about that quite a bit in my video about the entire history of Soviet rocket engines. And yeah, it's Energy was just an incredible rocket. And yeah, stand by for that. Again, hopefully I'm getting pretty far into the dialogue cut of this massive video, and Patreon members and YouTube members will get be able to see a version of it where it's just me talking. Basically, I have almost no B-roll, but what I'm going to do, because this video is so overwhelmingly complicated with literally like 100 engines on this chart, I will put the chart up on screen for you guys as I'm kind of talking about stuff. So you won't be totally left in the cold, because otherwise that would be a really hard video to watch, is me just sitting there talking to you for an hour and a half. Even, you know, as a perk, as a little preview, but still, that would be, I don't even think I could do that. So, all right, let's see. This is a fun one. This is from astronaut candidate Arthur Channel. This is 100 plus 6th grade students at
something like that. Yeah.
Beckman Middle School with Todd Cohorst standing by waiting to watch Henry the astronaut fly to space. That is so cool. Todd's responsible for education outreach, CDC's mission microgravity. That is super cool. Well, hello to all of the students over there at Beckman Middle School. For those of you tuning in, that's very awesome. We're excited to hopefully see your payload launch to space today. Again, this is rocket science, and there are delays to be. We have a new T0, my friends, and 0 time of 6:59. Interesting that they didn't just go with 7, but 6:59. I'm going to go ahead and tweet that here for a
about
second.
30 minutes
Give me
out.
1 second. Wait, what would that be?
No, not 30. Sorry,
That'd be
45.
1:59 UTC.
It says it up there.
6:59 Pacific, PM Pacific. That would be 1:59 UTC. Awesome. All right, so we've got the clock back to T minus 44 minutes and counting. That's not bad. That's a pretty quick recycle. That's good for those of us that are spaceflight fans. Again, for those of you, if you've been around before, watched rockets launch, especially test flight vehicles and first launches, I'm looking at you, Starship. You guys know what it's like sometimes when you're just waiting, going, is this thing going to launch today? And just that kind of those ups and downs. But you know that sweet and the what's the saying? The sweet and salty? No. The sweet and sour. There we go. You know, you have to experience the sour in order to enjoy the sweet. So sometimes having a vehicle scrub and kind of play with your emotions a little bit, just make it that much more rewarding. That's at least for me. I know that's true for me. Like, I have been to, I think the one that was maybe the ultimate for me to see in person was EFT-1. It was the first time that that NASA's Orion capsule flew on top of a Delta IV Heavy rocket out of Kennedy Space Center. And I think it only actually scrubbed one day, but that reset, I mean, it was a 24-hour scrub, but, you know, there's like a 4-hour window and we're sitting there going, is this thing going to fly? Is it gonna, you know, and just that whole thing. But by the time it took off the next day, I was like so excited to see it fly. I don't know, something about that. It's just a normal part of space flight. You guys, if you're new, you'll know. You might not be familiar with that, but those of you that know, you know what it's like. So let's see. I'm not sure what all these mean, but that's cool. Let's see. Okay, this is an interesting question from Tanner. I'm just getting here. I was wondering why you think, or wondering what you think of replacing stage 0 with a magnetic levitation train angled up the side of a mountain to get some initial velocity. So we get asked questions like this quite a bit. You know, why don't they launch from a mountaintop, or why don't, you know, or air launch like Virgin Orbit does? The simple matter of fact is, you know, you have to consider the cost of what it takes to have. Well, first off, for a mountain, it's really considered a big no-no to fly a fully fueled rocket over populated areas. So you'd have to find a mountaintop that is right next to the ocean. You know, any good-sized mountain likely isn't anywhere near the ocean, especially on an eastern seaboard, right? So if you wanted to say launch from 3 kilometers or something on top of a mountain. That's a pretty big mountain. That's still not very much vertical velocity either. You're still not, you're not getting any velocity. And there's a lot of velocity involved in reaching orbit. You need to be going almost 28,000 kilometers an hour, 17,500 miles an hour sideways in order to actually get in orbit, because you have to, think of it like if you launch if you threw a football, it's kind of going to go up an arc. But if you want to throw it further, you need to get a lot more velocity, and it will arc. And then you just think about the faster you're making something go, the further that arc gets. And eventually that arc gets big enough to literally just go around the world. And assuming you're above the atmosphere, there's nothing to slow you back down, and you'll maintain that orbit for a long time. There is, of course, still, it's not like the atmosphere just turns off. There's still a trace amount of atmosphere in low Earth orbits, so eventually stuff there does deorbit, but that's besides the point. That's the general concept. But as far as things like levitation, like magnetic, trains, or having something throw a rocket, you just look at what would the cost of that system be? What is the danger of that system if something goes wrong? And one of the biggest things is it's really considered a good idea to turn your rocket on before you let it go, right? So if you're throwing your rocket off of a levitation train, or maglev train, sorry, or some kind of plane, even like what Virgin Orbit does, you have the risk.
Tim is doing a fantastic job. You were saying?
Cost, how much fuel and how much bigger do you need to make the rocket to just launch at sea level, where you have infrastructure, you have people, you have roads, you have all of these things that are good when you're having to work on the rocket, work on the launch pad, get trucks out there with fuel, all of these things. Imagine having to get trucks up a mountain every time you have to launch a rocket. Like, it'd just be a logistic nightmare. There's a lot of these considerations, and at the end of the day, the general consensus for everyone is it's just a lot easier, a lot simpler to just launch at sea level, even though you're not getting that extra bit of vacuum optimization out of your nozzles, and you're not getting any extra velocity per se. But that's so looks like we may need to have you guys you guys might need to refresh. Some of this could actually be on YouTube's end. We've had this happen before where
I will refresh, Tim.
Us down, and this could be one of those days. I was actually having problems with YouTube earlier on my phone even, so who knows? Refresh this.
You could say what you want about Twitch and their ads. Lord knows I don't like them, but we don't have this problem here now, do we? So, despite the long, unskippable ads, which I absolutely hate, Twitch, thank you. Thank you for all the uptime. It's very rare we have a problem with an ingest server here.
Synchronous orbit can launch 630 kilograms. Now, if they were to launch just to LEO, like a more...
Is this in Wallops? No, wrong coast.
They could do a full ton to orbit. They could do, which is pretty impressive. But they are limited to 630 kilograms, but that's still a lot. That's bigger than everyone else that has flown to date so far in the small sat launch industry, or has even attempted to fly, including what Astra is currently flying, what Rocket Lab's currently capable of, and what Launcher 1 is currently capable of. So again, going to sun synchronous orbit, which is basically like a polar orbit, it can do 630 kilograms as opposed to Launcher 1's 300. Rocket Lab at that is 200 kilograms, and Astra currently is, I believe, 50 kilograms. I believe 50 kilograms, but I feel like that might be to just LEO. They might be slightly, but I think it's about 50 kilograms. So it's actually a pretty good size. You can launch pretty decent sized small, not just CubeSats, not just smaller 1U, 2U CubeSats and stuff like that. Small sats.
YouTube
you can just start getting into the bigger size small sats, which is really cool.
I'll take the good service.
They are tapping into slightly the upper end of the small sat launch industry, and they can also stack multiple satellites inside of their fairing and launch multiple small sats. So it's pretty cool that they have that capability, that it is on the bigger end of the small sat industry. And I think a lot of these companies are trying to find that sweet spot here. They're trying to find what's the cost of this launch rocket, what's it cost us to make it and fly it and do it again every time, what's that actually cost us, how do we make that profitable, and most importantly, where are the customers at? How many customers are there for our capability of rocket? It doesn't make any sense to make a bigger, more powerful rocket if there aren't those demands and payloads. At the end of the day, sometimes just the bottom dollar matters most for some people, as opposed to capability. If you're not fulfilling that capability, Why build it bigger, right? So so that's what all of these companies are kind of working on doing, is finding that sweet spot. Again, one of the things that I like about what Firefly did is the Reaver engine being relatively simple. It's simple and it's
a test
elegant,
flight,
and
isn't it?
it's very few parts compared to a traditional gas generator. Or
I think the context what he's talking about, Savvy, is for these small sat launchers. I don't think Starship is a part of that argument. I'm pretty sure he clarified small sat launchers. But even then, guys, it's about who can move the most payload to orbit. Seriously. But and Savvy, I do also agree with you. It applies to Starship as well. Doesn't matter the size of the vehicle. Sometimes building a bigger rocket, if that means making a more reliable rocket, is a good idea. They recycled. They worked the problem, and they apparently have found it. They recycled to the top of the hour.
we actually do the tap-off cycle,
Ga.
but it's as far as being simple and easy to manufacture.
No problem, man.
Without having to worry about a pre-burner and all that stuff. It should be a really good idea. So yeah, I'm excited about that. So 322 seconds says Flo.
A hard skeptical column for what, Savvy? For Starship? Yeah, that's fair. Or for the finding the sweet spot. I think the more payload you can move to orbit per year, I think Elon's metrics for big vent.
We're seeing some big puffs of gaseous oxygen. That is probably good signs of recycle going forward. So
how Elon looks at it, like with who can move the most per kilogram to orbit per year for the cheapest price, is the best way to look at it. In that regard, building a bigger rocket is better. So what you're looking at there is most likely a chill down on the Strongback. So they evac all the propellants out of this thing. There are fuel lines that go up this tower thing right here and into the second stage. You got to fuel rocket stages from the bottom. So there's two feeds most likely in this thing, and one's for liquid oxygen, the other one's for kerosene, right? And there's two propellant lines that go up the side of this thing and into the second stage tank. What you saw there was a chill down on those lines. So one of the lines has kerosene in it, or RP1 is what it's called. It's just a refined version of kerosene. All right, very energetic. It makes a nice, big, healthy explosion, but it's not very efficient. Think diesel trucks. It's very close to diesel fuel. That fuel line in there is not the diesel fuel line is not that's not cryogenic, so you don't need to chill that down. But the liquid oxygen line, because they evac all of the propellant out of there, the oxidizer and the liquid fuel out of it when they went to launch previously, they vented it. They vented the thing over. It was in fact not sus. Okay? So what they probably did there was they reintroduced liquid oxygen into the fuel line, and you don't just want to have the fuel line, go into the second stage liquid oxygen tank. Because the line, they vented all of it out, right? What they're going to do is they're going to fill it back up with liquid oxygen, chill down the pipe to get it to be cold, so none of that liquid oxygen evaporates into gaseous oxygen, right? See, there's the vent opening again. And they're going to fill it up. They're going to fill it up with liquid oxygen again. When they fill the thing up with liquid oxygen again, you see the vents open like that. That's what that is. That's a chill down. So they're basically chilling the fuel lines and filling the fuel lines completely up with liquid oxygen. You don't want anything else going into your liquid oxygen tank but liquid oxygen. So they most likely just did a chill down because they filled this thing back up with fuel, the launcher, to top off the tanks. Now, why do you need to top off the tanks? You got to top off the tanks because liquid oxygen, or for oxygen to exist as a liquid, it needs to be extremely cold. If it's not cold, it'll turn to gas, like what you're seeing there. So, because they're storing this liquid oxygen, which is really, really cold, at high pressure, the liquid oxygen boils. And it boils off, like if you put water on the stove. It'll boil, and then you'll have no water left. It'll just turn to gas. It'll evaporate. Liquid oxygen does that. So you constantly need to vent these tanks. You constantly need to vent, and because they stood down and they pushed the launch basically an hour out because they aborted, right? They've been venting the tanks. They brought them down from flight pressure, and they've been venting the gaseous oxygen overboard of the liquid oxygen that's been boiling off, right? So they got to re-chill down the lines, and they got to top the tanks off, basically. Again. They got to top the tanks off again. What you're seeing there is a chill down. Right here. I don't know if those are first or second stage vent lines. That's the first stage vent line right there. I know that that's the first stage vent line because it's coming from the rocket. This thing down here is not coming from the strongback. It's behind it. And that vent line is right in line with the top of the liquid oxygen tank. You can tell that this is the top of the LOX tank because of the way it is. No, because it has a lot of condensation on the outside. Basically, the tank gets really cold when you fill it up with really cold liquid oxygen. That causes the atmosphere that's on the outside of this thing to actually condense because it's so freaking cold, and ice accumulates on the outside of the booster. From this basically this white stripe here, you can see that that's the top of the liquid oxygen tank right around where my mouse cursor is, and then the vent line is always on the top. You fill up rocket fuel tanks from the bottom with liquid, and then you vent out the top with gas. Did they drain down the rocket? And they had most likely a little bit of boil off. They did not take the fuel out of it. No. Once again, remember, it's about getting it into a flight state that it was at the go no go pole. So they brought it down from flight pressure, they recycled it, they repressurized and depressurized certain systems, and now it's not the kerosene. Kerosene's fine. They got to top off that liquid oxygen because it'll boil off, dude. The LOX tank knows where it is because it knows where it isn't. More Philly flooding. Cool. Gases boil and rise out the top of the tank. That's right. What's that, Cajun? Rocket Guy, what do you think? Think they're going to do it? Hey, Synerd. Thanks for the resub, man. $19-monther. And Vulcan had a 22-monther in there. Someone say rocket launch? Let's go, modern SRB-less Delta 2. Nice. Draining the fuel out of a rocket is a great way to watch it collapse in on itself. With certain fuel tanks, Bionic, yeah, that's absolutely right. With certain tank designs, though, some rockets can stand up on their own. But a lot of rockets use fuel tank pressure to keep the rocket nice and structurally rigid. That's very true. If you're using a balloon tank design like early Atlas missiles, or even to this day, Centaur stages, the tank walls are thinner than a dime. So they have to keep it pressurized like a balloon, or else the thing is not going to stand up by itself. If you lose pressure, the thing will crumple like if you stepped on a soda can. It's actually not that far off. MS, what do you got? Just imagine another decade or two and Blue Origin will go to orbit. Oh, come on, man. Yo, boss, 6313 sub. What's up, dude? And Rocketology with the raid. Thanks, man. The rivers in Philly rose by at least 15 feet. Okay. What material are they using for the interstage? I believe it's carbon fiber or carbon composite, but don't quote me on that one, T-Man. Super Heavy is a semi-balloon tank design. Yeah, those it can stand up by itself because we've seen them open the access hatches and go into the tanks before. Hey, 9-month resub. Thanks, man. Rocketology, thanks for the raid, dude. You guys know my buddy Rocketology. Fellow aviation geek and plain nut Kerbal player. Also DCS player. Can beat me in a dogfight in DCS, but don't tell him I admitted that. 40, what's going on? Give Rocketology a follow, guys. If you like the kind of content that I produce here, you'll probably like Rocketology. He's my boy. You're my boy. Rocket, you gonna look out the window and see this or what? What's the gap on the front of this rocket? I thought the bulkhead of the first stage tank was the bottom of the second tank. Would that mean there's no gap? So, okay. You have the top of the liquid oxygen tank right here. That's the inner stage. So that's the aft skirt of the second stage. So the rocket engine is right there. And then, see from here to about here, Flykin, that's the RP-1 tank. And then from here to about there, that's the LOX tank. They were pressurizing them during transport to the pad. I mean, between the two frosty parts. Now, that one I'm not sure. There's some kind of band in there. I'm not 100% on why that's doing that. I'll be honest with you. It could be some kind of structural band or something. Or carbon or something. I'm not 100% why that one happened. Why that's happening right there. It could be a different material. Could that band be part of the strongback? No. When the strongback actually retracted, it was still there. Do they have to pressurize whichever is the lower tank on Starship before they load the upper tank with propellants? That's probably part of the fueling sequence. Cyanide, it's actually better to do both of them at the same time. Fill the LOX and the fuel tank at the same time. That's the right way to do it. I think it's more like a soda can, pressurization to prevent the weight from causing issues, but technically able to stand on its own. That sounds right. That caused one of the failures, emptying the bottom tank while the top tank was full. Yeah, you're not wrong. Actually, not sure if they use a common dome design. Yeah, boss, I don't know. I'll admit, guys, I don't know that much about Alpha. I'm gonna have to do some reading. Yeah, C-22. There's the Atlas Aegina just keeling over on the pad. What's PCS? I don't know. Where are you seeing PCS on the screen? They do not use a common dome. Interesting. How big is this rocket? About 100 feet, Swishio. So I can get you the exact. Give me one moment. Uno momento. I know that's Spanish. So the rocket is 29 meters tall, 95 feet. The diameter is 1.82 meters. It's a 6-foot core diameter. And it can move about 1,000 kilos to low Earth orbit or 600 to sun synchronous. So, Swishio, it's actually a lot like Vega. This is close to a Vega rocket in performance. You say that guy could... DCS, Digital Combat Simulator. Why would you use a common dome? Saves weight. Why wouldn't you use a common dome? It could be ease of manufacture velo. A lot of rockets that do not use a common dome, like SLS for instance, have a huge differential temperature between the fuel tanks. If you have hydrogen at minus 500 Fahrenheit and you have liquid oxygen at minus 293 Fahrenheit, well, you're talking about a pretty big temperature differential. That's a big change in temperature. Your LOX tank can actually heat your hydrogen tank despite it being minus 300 Fahrenheit. Yeah, it'll actually heat it. Some rockets don't want to do that because they don't want to take the performance hit. You have to have an insulated common bulkhead, so it's easier to just make two separate tanks and use an interstage, like SLS or the external tank or Delta 4. But it ends up being more reliable. Yeah, it's right in between Vega and what's on the other side of it. On the other side, I guess, would be relativity, right? Relativity would be in there. I didn't think... yeah, it's somewhere down there, Cynerd. Yeah, it's really freaking cold. Yeah, almost 0K. Yep. Mm-hmm. Oh, Hellfish, savage. Okay, we're sitting inside of 23 minutes here. They should have another go, no go poll. Liftoff is 59 past the hour right now. So if you look at your clock, when it should have X hour and then 36. When that 36 says 59, then that's when we're going to lift off. Or that's at least when they're trying to lift off. Do most rocket companies use metric system? All rockets are engineered in metric, Jay. I mean, some of them might not. It really depends. It really depends on the company. A lot of them engineer it in metric and then back convert it to imperial. You know, if they're like explaining things, like in the press kit, it says it in, or no, not on the press kit. On the wiki page, it says imperial, and then metric after that. Yep. See, you're looking right there. That's your first stage oxygen vent right there. So the second stage engine is riding inside of this. This part right here is really hollow. There's a second stage engine sitting on the bottom of the second stage right here. Oh, they had a vent chill down out of the strong back there. Now up there on the other side is your oxygen vent from the second stage liquid oxygen tank. The top of the first stage oxygen tank is right here. So you have liquid oxygen tank on the first stage. Interstage here, which is a structural component that connects the two stages. It's in between the two stages, hence interstage. And then there's usually a separation mechanism here on the top of the interstage. That's where the separator is, where that white band is, right there. And then riding inside of the interstage, because it's a hollow cylinder, is the second stage engine. It's sitting just above that gaseous oxygen vent, right here, right where my mouse cursor is. And then, on top of that, you have the second stage RP1 tank, and then the second stage liquid oxygen tank on top of that. On top of the second stage liquid oxygen tank, you have a payload attachment fitting. The payload attachment fitting, or PAF, is where, well, the satellites would be connected to. But it's also where the fairing attaches to. This oblong thing kind of up at the top, that is an aerodynamic shell to make sure that the payloads don't get blown away when they're going on the way up. It's a fairing. It's designed to push the air out of the way to protect the payload on the way up. Fairings also protect against acoustics, various acoustics like vibrations and thermal as well. They basically keep the payload isolated, and then when the rocket gets up out of the atmosphere into space, they'll pop off, and then the second stage is clear to deploy. Is this a test? Yeah, game, this is a test. You're looking at Firefly Alpha. That's a Firefly Alpha rocket. This is the Dream mission. You're looking at Flight 001 over there. This rocket is taking off from Vandenberg Air Force Base, Vandenberg Space Force Base, Space Launch Complex 2. Slick 2 was previously a Delta 2 pad and serviced Delta 2 missions all the way, basically from the late 80s all the way up to 2018. The last rocket to fly off this launch pad was a Delta 2 called delivering the IceSat-2 payload for NASA. After that, they abandoned the pad, and Firefly actually picked it up and scored it for a decent price, and now we're ready to go. Slick 2 is about to be active again if this thing goes. The Mars Climate Observer plowed into the surface of Mars because NASA used Imperial. Yeah, Lochner, no, that's not true. I mean, the same argument could be made that the Mars Climate Orbiter crashed onto the surface of Mars because Europe used Imperial. I mean, you can flip that either way. I'll say this once, I'll say it again. Measuring system is down to a project management thing and what makes the most sense. And everybody here is going to be like, well, the metric makes the most sense, EJ. Yeah, I'm not debating that. It does. But as long as everybody's on the same page, it really doesn't matter what measuring system you use. I'm not saying that metric is harder to understand or imperial is harder to understand, even though it is. Metric's a lot easier. If everybody's not on the same page, it's a management problem, not a measuring system problem. Don't get confused. You can make equal arguments saying that, oh, well, the Europeans should have engineered in imperial. Oh, well, the Americans should have engineered in metric. That's a project management problem, not anything else. No NASA engineers tested the software. Like I said, management problems. Dude, like, don't get me wrong. It should be engineered in metric. Like, I'm not some punk that's like, oh, it has to be in feet. Like, I get it. Metric's way easier to understand. But if everybody's not using metric in your business or on your project, then whose problem is it? It's your problem. You know what I mean? So as long as everybody's on the same page, you can measure it in kilofeet for all I care, right? All right. Inside of 17. Whoa. Oh, they're showing the static fire. I was like, what's going on?
12% O2. 16% on O2.
So they did the static fire there. That was 2 weeks ago.
I love that. I love that. I love the burn, baby, burn. So that was from their static fire.
They stole that from me, man. They didn't. What are those bags around the engines? Thermal blankets. You don't want heat getting into the part. You don't want heat being exposed to the parts of the rocket engine, Flecken, that have cold propellants in them. Liquid oxygen. You don't want to preheat the LOX before it goes into the engine. Bad idea. The only thing that should be going into those engines, the only thing that should be going through your liquid oxygen lines is liquid oxygen. You do not want gaseous oxygen going in there. Because if you do, it's going to screw your mixture rate inside of the engine, and your engine will run fuel rich and stop working. It'll run fuel rich, it'll cool down. That'll be good, but also it'll stop working. You'll make a nice big flamethrower. A lot of, like on the bottom of a rocket, a lot of low pressure gets stuck. A lot of low pressure happens, and heat gets stuck behind the rocket. One, because you have those 4 flamey boys at the bottom. No, you have 4 rocket engines at the bottom. And when the rocket engine is going up, the area between the end of the nozzles and the bottom of the rocket, a lot of heat gets trapped there. A lot more than you think. So think about it like this: the rocket is pushing all of the air out of the way, right? And the rocket engines at the bottom are making a vacuum, and that's sucking the air away, like on the Saturn V, right? There's tremendous low pressure in there. Right in this area between the bottom of the rocket and the engines, there's crazy low pressure, even while the rocket's going up into space. And basically what happens is heat gets trapped there. Because it's low pressure, it's very easy to heat up that whole area, and that heat's going to look for something to leach onto. Because a lot of things are conductive of heat, because it's not going to be able to conduct all that. It heats up the air really quick because there's not a lot of air to heat up because it's low pressure. So thermal's down at the bottom of the rocket, big deal on every rocket. That heat's got to go somewhere. Make sure it goes away from where your cold propellants are. It'll go right to the rocket's thighs. You like rocket launches, don't you, Squidward? They're flamey guys, not rocket engines. This is a science channel. All right. So we're 13, inside of 14.
Right T-minus 14 minutes. RC, please contact the range and coordinate to begin recording RF tapes at T-minus 10 minutes.
Complete.
Okay. Some of the stuff will sound familiar. We had this, they're going through their checklist as they go.
The flight controller, the launch director just asked the range coordinator, RC, to basically, that's like the air traffic control for the rocket, for the launch area. Launch areas have these zones around them called testing ranges, okay? So Cape Canaveral in Florida, right, and Cape Canaveral Space Force Base have the Eastern Testing Range, or ETR. That's the range that kind of oversees the area where the rockets take off, right? Over here we have the WTR, the Western Testing Range. The Western Testing Range is basically the traffic control. They're basically making sure that there's nothing around, making sure the weather is okay, there's no planes flying around or boats out there where the first stage is going to come down. They coordinate with the range to make sure that your window for launch is clear.
So everything's still looking good. That's
Probably
exactly
not done,
what we want
but,
to hear.
I don't know,
We want to see them
maybe.
continue to move through this process. Yeah, very cool. All right. And this is cool. We have James Pettit
Show
out there,
Simba
literally
one.
hoping to see it from his backyard. That is cool. Living on the West Coast, living in California today would. And actually, I'm not
We'll now
asking
review
for a
actions
scrub.
on CD1. In the event of abort, you'll perform the following steps. You'll confirm there are no fires around the engine, utilizing
I'm
fire
working on
exits
it, Flag.
called out by LD. If there are no fires, GC will turn off the world purge. We'll confirm vehicle health. The pre-valves are closed. Helium bubble is active. S1 fuel tank is maintaining between 30 and 36 psia, as read on A1S1 CFTs. We will verify other vehicle tanks are vented.
What's
We'll confirm
PSIA,
ground
Rocket
side
Guy?
health.
I don't
The
know what
TCAP
that
tank is
means.
vented. TVC tank is vented. Spin system
I know what
is vented.
PSI is. What's PSIA?
Cavity purges are active. We'll confirm with the range rotated disarm and power down the ESADs, and then we'll power off stage 1 and stage 2 FTS. We'll transition back to manual power. We'll re-engage the strongback via command changes on the hydraulics page.
I'll tell you in a
Error
second.
code 016 is expected in abort after T-minus 30 seconds. In the event of liftoff, operations team will move to the ground net and perform PRC MLP 1438
Yep,
and
yep,
RC
that's-
will
okay,
perform
cool.
1435 set operations on CD1. In the event of a hang fire, we will perform PRC MLP 8304.
All right. Basically, what the launch director just did was said what they're gonna do if they see an abort. They said what you should do if you see something that you don't like, you'll call abort, and then here's what we're gonna do. We're gonna take the rocket out of its flight state again. Basically, do the stuff that they already did. Take it out of the flight state, disable this, enable that to make sure that the rocket is in a what's called a safe mode. No, not like safe mode like on the computer, but also kind of. Safe mode is better than a failure mode. True story. So that was basically the procedures for what happens if there's a contingency event. So something goes wrong, or if you see an abort.
That is being backlit, illuminated. It creates this beautiful thing called the twilight phenomenon.
GSW1 on GSW9.
And it's just stunning. It's
I'll check it in
absolutely
a second,
stunning.
Limbo.
So if this would to get pushed back, we would at least have that bonus
PSIJ is basically
of the
the
next
relative pressure
opportunity
in the
in this
pneumatic
window.
system
Might
for
be
the
right
atmosphere.
during the twilight phenomenon. So I wouldn't complain if that was the case. Again, remember this is their first attempt
I got you,
ever,
Rocket, got it.
so we need to offer up some grace. And
Will it be a
again,
twilight launch?
thanks to Firefly for
Looks
allowing
like it.
us to stream this and for this level of transparency. Even the comms. I mean, we're hearing comms. We have trench cam.
No.
They did a pointy end up, plenty end.
So Anglo, what's going on here? This is a test flight. This is a test flight for Firefly Aerospace's Alpha rocket. This is the first one. This is the first time they're ever launching this. This rocket has never launched before. This is an inaugural flight, so it's a test mission. This guy's gonna go into kind of almost polar orbit. So instead of the orbit going like east to west around the equator, this one flies over the North and South Pole fairly frequently. It's 137 degrees inclined for the nerds. Meaning they're launching southwest out of Vandenberg. That's where this is. This is Vandenberg Space Force Base. This is Space Launch Complex 2. Vandenberg Space Force Base is a launch, the U.S.'s West Coast launch site. It's about 100 miles northwest of Los Angeles, 160 kilometers northwest of L.A. Beautiful country. Beautiful part of the country, to be honest with you, just on a side note. But that's where the Western Testing Range is. Vandenberg Space Force Base is operated by Space Force Delta 30, and that's basically the range coordinators, and they operate the base. It's the Space Force that operates this base. Previously the Air Force before that.
Yeah, I'm a big fan. This, like I said, this does mean a lot to me to be able to be the official stream provider for them. I don't know why they're trusting me to do this. If you're new here, hi, welcome. I'm Tim. I don't work for Firefly. So the fact that they're trusting me to just talk about stuff, pretty nuts.
Fuel bubbling? It most likely wasn't fuel bubbling, but I didn't get that part, dude. I don't know. The fuel can bubble. I mean, the liquid oxygen is boiling.
This is a great question here. Asking from Oscar if I would make a video about tap-off cycle rocket engine.
It's gonna be hard to see it.
It isn't in the Raptor King of Rocket Engine video that I made, where we talk about engine cycles. That is an upcoming video where I will just do a video only about engine cycle types, because there are other ones that we didn't talk about in that video. And I think it would honestly make a lot of sense to just make a dedicated video about how you can make a rocket engine run in different cycle types. We can talk about tap-off, we can talk about the bleed expander cycle and the expander cycle. There's a lot of different tricks up sleeves that we didn't even begin to touch on in that video. So it'd be really fun to do a comprehensive video for you guys, because the tap off cycle they're using here is really unique. And like I said, no rocket that utilizes the tap off cycle has ever made it to orbit. I don't even think there's been a rocket that's attempted to go to orbit with a tap off cycle. It is a very unique solution, and it's so cool that they're utilizing it on
the only other rocket that uses a tap off cycle is New Shepard with its BE-3 motor. So there have been suborbital rockets with tap-off cycles, but not orbital rockets. The subtle shade.
Stage 2 inside the inner stage is wiggling. They kind of wiggle
Cool,
it. You can't see that visually.
That's cool.
So that is a sensor thing. They might have a camera up in the inner stage that would show them that wiggle to confirm, but...
it's a NOTAM banana. Yep.
But yeah,
fly zone.
I'd say tap off as far as the
temporary flight
moving parts and
restriction.
everything
So it'd show up.
is
The
about as
NOTAM would
simple
show
as it
up
gets
on the
for
flight
bipropellant outside of like pressure fed and electric pump fed. It's a really unique
gas generator
solution.
standard.
And like I said, it's not the most efficient thing in the world, but that efficiency doesn't really matter at the end of the day, right? You're really worried about how much does it cost me to make an engine?
T-tab. Triethyl aluminum and triethyl borane, they're pyrophoric igniter fluids that this thing is going to use. If they get to the point where they launch the engines, you're going to see a flash of green flames come out the bottom. Basically what that is because triethyl aluminum and triethyl borane, when they combine, they're pyrophoric. So if they find oxygen, they'll explode. They use that initial spark to basically get the tap-off cycle working on the 4 Reaver engines. That's what starts that's the starter. It's igniter fluid. Like if you took a grill and you sprayed lighter fluid on it and threw the match on it. You know, same concept.
Shuttle versus Baran.
Okay, so this right here is a gas closeout. So I said a little bit earlier when they had a huge vent like this that they're filling this back up with fuel to top off the second stage. Now they're draining it. Now they're depressurizing that line, so all the liquid oxygen in there is being exposed to atmosphere because they opened the valve right there. What it's doing is the atmosphere is heating up all the liquid oxygen in the line and it's purging it out. It's getting all of the LOX out of there. And you notice they did that right when they retract the strongback. The reason why you don't want to do that is because you don't want to have liquid oxygen and RP1 inside of this thing. You don't want them inside of the strongback. It carries the fuel lines for the second stage right here. When the rocket goes off, if it does leave the pad today, when it goes off, it's, you don't want any propellants here. You want propellants inside of this thing. Long story short, it can damage it. If the flames from the rocket engines find that liquid oxygen that's venting because they didn't chill down the line, it could damage the transporter erector. This thing on the side here, it could damage it. You don't want your pad damaged any more than you want your rocket damaged. So they do a gas closeout. They get all the liquid oxygen, all the stuff that makes stuff explode. They get it out of there.
Liquid oxygen and expand it into a gas, heats up and turns into a gas that expands 1,000 times. So you can't have that inside the vehicle anymore. So you vent it out, and that's what you're seeing, and that's totally normal. Again, think of like opening a freezer on a hot day or something.
FTS confirm FTRs are active and ranges transmitted.
Good freezer analogy.
FTRs are active and ranges transmitted check channel 4.
Note the arm enabled 2
Pretty much, Ivo, yeah.
For the east side within 30 seconds of receiving the arm enabled 1 command. FTS send arm enabled 1 command to all east sides.
Arm enabled 1 command being sent in 3, 2, 1. Mark.
Yes, John. Yeah, it happened a couple of times.
FTS send arm enabled 2 command to all east sides.
Arm enabled 2 command being sent to all east sides in 3, 2, 1. Mark.
FTS confirm all east sides are enabled.
All east sides are enabled and armed.
Flight termination system. If something goes wrong, the flight termination system will get rid of the rocket for
you. All right, so that it means the flight termination system is officially active.
You don't
on the
want
rocket.
that. You don't want that unless the rocket goes off
course. With this vehicle.
Vandenberg.
T-2 gate complete.
Copy.
Vandenberg Air Space Force Base mustache. It's in California. Yeah, Far, yeah, you're not wrong. LOX is, yeah, icky stuff.
All right.
Make stuff explode real good. Yeah.
Our heart race is racing again.
Really?
Yeah. So again, flight termination system armed. if
So
this
they
thing gets
closed
off
out
the pad
something up-
and starts to
they
ascend,
closed
and if there is an anomaly where guidance
They closed
doesn't work
out
correctly or
something on the
something,
pad. You see
they
that
have
vent?
the option of aborting the rocket, which will terminate the rocket and make sure it doesn't fly towards Los Angeles or nearby Lompoc or Santa Barbara.
They're
or
not
something like
flashing.
That
That's
is
just
a
the
requirement for orbital
it's
launch
just the
vehicles,
camera.
especially when you have this much payload and this much fuel on board. They have to make sure the public is safe. That is what the flight termination system is for. But yeah, they're going
First
for it
one.
though. Again, guys, remember this is their first ever launch attempt.
See?
So we'll be listening in here during these last
Scardo,
2 minutes.
It's their first launch.
Or
This
any
is
kind of
Firefly
call-out.
Aerospace's first
T-minus
try to try and
2
get to
minutes.
space, man.
TE has
very-
finished
it's
the
not-
final LCC.
It's not very often
Checks
you get
for
to see
launch.
this.
This is the final commit for launch.
Okay.
TE.
Send it again.
Launch director.
Go.
LDA.
Send it again, my guy.
Copy LDA. VC, please verify alpha
Send it,
transitions to
bro.
autonomous mode in T-minus 30 seconds.
We'll go.
The LD just said send it on the comnet. Yes.
Send it again. I love that. That was referring to the rocket. He's saying send it, and he had already said that on the net
Wait,
earlier. So
I'm just gonna send it. Just gonna send it.
saying send it again. They're ready. They are ready to
Getting it.
launch this thing. I love that.
80 seconds. Okay, there's your vent down system. I'm not
scared
sure
me.
what's
That
making
was
that
bad.
noise. But that's them getting gas out of lines. They're purging the lines out. You don't want anything that could get near the rocket on the pad to have fuel or anything in it. Basically want to evac all of that stuff.
60 seconds.
Because in this area right here, it's going to get very hot.
Toxic pressure started.
Like this area, not
Trench
over
cams
there.
looking
or over
awfully
there so
condensed
much.
there.
But right in this area right here, it's going to get hot. You don't want you basically they got to get everything away
To
from
stop
it.
the count, operators please declare abort on CD1 and DC will abort the Odyssey system.
Nope.
DC at T-minus 30 seconds, verify alpha transitions to autonomous.
Wait.
30 seconds.
Wait a minute.
2 engine levels.
That could have been a routine call. Hold on. Hold up. Don't. The
20.
the count's still going. That could have been just a regular call.
Oh, just that little bit of gimbal there.
15.
Okay. All right. Hold the Fs just for a second.
Here we go. Good luck,
10.
Firefly.
9. 8. 7. 6.
All right.
5.
Watch the reavers.
4. 3.
Fly, baby, fly!
0100 Zulu.
RC transition operation procedures to PRC MLP 1435, IT commits to PRC MLP 1457, report anomaly. Please confirm I have no fires on the pad. I have no visual. Please confirm no fires on the pad. Moving to ground.
I'm looking. I'm about to send them all.
That was just a
pad
routine
sweep.
call. They sent it. All right,
Cameras
here
are
you go.
sweeping the
We're
pad.
flying.
Plus 32 seconds.
Stage 2 pressure's
Prop
up.
call.
Prop is nominal.
Propellant lead is
Oh my God, they're doing it.
reporting
You
that
see?
the propellant is nominal.
I'm taking a dip in
Yes.
VMAG. There's no
Again, this
there's
is
no
a-
fires on the pad.
Avionics.
Responding AVI.
I don't think so, Flykin. Everything
one
looks
pressure
good here,
profile
guys.
nominal.
That doesn't look bad. I'm not
Avionics
seeing
power nominal.
The
Telemetry
first
is
ever
nominal.
attempt.
looks all right to me.
This is their first ever attempt at going to space and going into orbit
IR,
ever.
yep.
And they're
Oh.
coming up right now on maximum aerodynamic pressure. That is the moment where the vehicle will experience
Plus 130.
the most amount of aerodynamic pressure. So this is when you're really testing your fuselage. Is it going to hold up?
That's
We are
a shot
going
of
through
the
that
second
right
stage
now.
engine
So the
inside of that
vehicle
hollow
is clearly
tube, the
holding
inner
up.
stage.
That is a great milestone. We might even hear Max Q call out on the
Not yet
comms net.
supersonic.
No, the
Not
vibrations
yet
from the
supersonic.
rocket
That's
engines are
maybe
screwing
not
with
great.
the camera.
The
That
vehicle, there's a
happens.
chance it could be slightly underperforming, but again, we'll wait to hear official call-outs here. But this, again, first launch attempt ever of this vehicle. It's unbelievable. They got off on their first try on their first day of their first attempt ever. This is unbelievable.
Should be about 20 seconds
Again,
until
if they get to
main
stage
engine
separation,
cutoff.
that's going to be a huge milestone.
Vehicle is supersonic.
No,
Vehicle
30
is
seconds,
supersonic.
excuse me. Okay, broke the sound barrier. Yeah, I got it, IQ.
That's a good.
Oh!
Pretty close anomaly.
There has been an anomaly.
Oh!
The anomaly team to procedure MLP.
Ho, 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 ho.
Shoot. Oh man.
Oh, yep. Yep, that didn't work. Oh.
Oh, that was impressive though. That was impressive. I was actually speechless. I just really didn't think they would go for it on their first launch window opportunity ever. Wow.
It didn't get to main engine cutoff.
Wow.
I don't know,
Everyone,
floating.
just send Firefly your love and say thank you, Firefly, for allowing us to stream that. I mean, they didn't have to do that. They did not have to do that at all. They absolutely
Test
just
payload,
showed
Boris.
warts and everything. Give mad props. Everyone, just here in chat, just everyone say congrats, Firefly, because they did a lot today. They did a massive amount of impressive milestones.
Rocket,
I
that's
mean,
what it
even
looked
getting
like. It
off
looked
of
like
the pad
it looked like it was
with your
going
first
slow.
orbital rocket is a huge milestone. So I'm still incredibly proud of the teams at Firefly, and I'm again so thankful that you let us stream your first ever attempt. No one has done that in recent history. No one has tried live streaming their first attempt because they're normally pretty ugly. That actually looked pretty good. That looked pretty darn good. It looks like they were almost to stage separation. So again, huge congrats, Firefly. Everyone, round of applause in chat. This is not even a need for F to pay respects. But you know what? I'll let you guys go for it. Let's hear those Fs to pay respect for Firefly and the beautiful Alpha rocket on its first launch attempt.
Don't do it. Don't listen to him.
I can.
Don't listen to him. This is my stream. Don't listen to him.
Man.
Oh, God damn it, chat.
That was a great first attempt. That was an amazing first attempt. So the cool thing here is they'll only learn from here. Think about how much data they just gathered about the rocket. How much data they have now that will actually give them flight conditions of their engines, of their tanks, of their of their helium pressurization, of their avionics. Actual data is worth so much money and so much time. You can simulate things all day long, but until you actually go out there and fly and actually see how these things that you're simulating work in the real world, you don't know. You just do not know. So that was unbelievably impressive. I'm sure the teams, I'm sure they're disappointed they didn't make it to orbit, but frankly, I mean, that would have been that just really really has never happened for a first time for any rocket company. So again, hopefully they learned a ton. That is almost 3 minutes. Yeah, I did hear on launch call out there actually was someone that said T-minus 4 seconds or so, that someone did say aborted. So maybe they'll learn something that was off nominal. But
all right, they cut the feed. We're scrubbing back. Let's take a look. Hey, dude, that abort call was awfully close. That was inside of 20 seconds. They wouldn't be calling abort procedures that close. I want to listen to that again. I got a little confused there for a second. Let's go.
CD1 and DC will abort the auto sequence. DC at T-minus 30 seconds. Verify alpha transitions to autonomous.
Yeah, no.
30 seconds.
2 engine levels are at 2%.
Yeah, it just sounded like regular calls from the flight director there.
15.
Here we go. Good luck,
10,
Firefly.
9, 8, 7, 6, 5, 4, 3, 2, 1.
That looked real good.
0, 0, Zulu.
RC transition operation procedures to PRC LP 1435. IT commence PRC LP 1457. Report anomaly. Please confirm I have no fires on the pad. I have no visual. Please confirm no fires on the pad. Moving to ground.
It sounded like it, NASA man. Yeah.
I'm looking. I'm about to send them all.
Test payload
pad sweep.
Vulcans.
Cameras are sweeping the pad.
Plus 32 seconds.
Stage 2 pressure's
Prop
up.
call.
Demo, yeah.
Prop is nominal.
From what I'm looking at, and you guys kind of said it in chat, it looked like an engine was underperforming because it took off the pad okay, but it took a long time to get to supersonic. Timmy said could be underperformance, and that seems to be what's going on.
Responding AVI.
Uh-oh.
S1 pressure profile nominal.
Avionics power nominal.
I don't know. Let me look.
First ever attempt. This is their first ever attempt at going to space and going into orbit ever.
Yeah.
They're coming up.
Something's going on over here. That's not what you should be seeing. See that right there? So that looks like ice coming off the booster. Ice shouldn't be coming off the booster at a minute 30 into the flight. Something's going on over there. Yeah, demo. Yeah, I said that on the way up, dude. The way the cameras were freaking out, like if you get that not interpolated, that kind of like fuzzy image, like what we're getting here, that's usually consistent with nasty vibrations.
Right now on maximum aerodynamic pressure. That is the moment where the vehicle will experience
Plus 130.
the most amount of air.
Did they not call pressure profile anomaly there? Let me listen.
S1 pressure profile nominal.
Stage 1 pressure
Avionics
profile.
power nominal.
Stage 1 pressure profile is nominal. Okay, so something to look at here, fellas. Look at the way the rocket engines are from the IR picture. The plume is going down, but look at this part right here. Look at Lavi's tweet of the boom. Oop. Tweets from the company. What's up? Alpha experienced an anomaly during first stage ascent that resulted in loss of the vehicle. As we gather more information, additional details will be provided. Prior to entering the count, range cleared the pad and all surrounding areas to minimize the risk to Firefly employees, base staff, and the general public. We are continuing to work with the range following all safety protocols. Yeah, mouse critters. I cover every rocket launch, dude. It's what I do, man. See, okay, so fellas, see the way the flames are coming off? The flames are pointed down. The rocket engines are pointed down, but the flames are going this way. See this right here?
S1 pressure profile
Now,
nominal.
that could just be wind, but it looks like the rocket's kind of doing this. I don't know. But see that? That doesn't look right.
This is their first ever attempt at going to space and going into orbit ever.
I saw it, Vulcan.
They're coming up right now on maximum
ago.
aerodynamic pressure. That is the moment where the vehicle will experience
Plus 130.
the most.
You're still getting problems over here. Whatever this is, I'm not sure if that's normal or not, but
amount of aerodynamic pressure. So this is when you're really testing your fuselage. Is it going to hold up? We are going through that right now. So the vehicle is clearly.
You see that camera's shaking? That's a lot of vibrations.
Holding up.
Sounds like
that
an
is
engine,
a great milestone.
Right.
We might even hear Max Q call out on the comms net.
I don't know for sure.
Not yet supersonic. That's maybe not great. The vehicle, there's a chance it could be slightly underperforming, but again, we'll wait to hear official call outs here.
That's what I'm thinking, Rocket Guy.
But this, again, first launch attempt ever of this vehicle. It's unbelievable. They got off on their first try on their first day of their first attempt ever.
Yeah.
This is unbelievable. Again, if they get to stage separation, that's going to be a huge milestone.
Vehicle is supersonic.
Vehicle is supersonic.
So they had a supersonic call out at 2 minutes 20 seconds. Per the flight press kit, like what you were saying, Thomas, they were supposed to go supersonic at 1 minute 7. This is consistent with an underperforming first stage. Something's going wrong with those Reaver engines down there. And once again, the hard part, guy, anybody can pressurize propellants inside of a tank. That's not the hard part. The hard part is the flamey thing at the bottom, the rocket engines. Propulsion is always going to be the most complicated part of the rocket, by a long shot. So, you know, these callouts are consistent with first stage underperformance. That could be a million freaking things, especially if it's the rocket motors. That could be anything. It could be, there's so many different things that could be. It's, all right, what's this tweet from Jack saying? Oh, you got some great pictures. And then he got the explosion. Yeah.
Wow.
The first picture here looks like engine out.
Anomaly.
Oh.
There has been an anomaly.
Move the...
All right, I want to hear this one again.
Wow. That's a good...
Anomaly.
Yeah, the thing did this. It did a corkscrew and then they blew it up. Something went pretty wrong there. But here's the thing, guys, and I don't mean to echo Tim's words, but for a first attempt, that's pretty damn good. Pretty damn good for a first try. There's always known knowns and then there's unknown unknowns. What that means is you're not gonna know what it's gonna do until you freaking send the thing. That's one of the kind of the tough parts about rocket science and engineering these things. You could do 1,000 bajillion different simulations and then you send it and it'll give you a different result, because at the end of the day, you're never going to know for sure if it works until you put one on the pad and launch it. So, yeah, they showed all of it. It was really cool. Really cool. Yeah, the fact that, yeah, Spoon, that's right. Stream chat, hey, thanks for the resub. Hey. Underperformance, but hey, not bad, really. I want to see what's going on here. That one shot of the engines that we get. You see anybody see anything weird? Rocket guy, you see anything weird coming from here? See the tearing that's going on? The tearing that's going on from the vibrations here of the motors. Look at that. The rocket engines give out noise at frequencies that can actually disrupt the... They mess with the cameras. It's kind of crazy. That's from the sound, believe it or not. Here, let's watch ignition. Oh, you can see the green. There's the green right there. Let's watch the ignition in slow motion. See what we got. Oh no, that's just sunlight.
There you go.
We're gonna go for slow-mo. Alright, let's take a look. How did that camera survive long enough? It's probably looking at the rocket through a mirror, guys. So the camera isn't just pointed at the rocket engines, okay? You have a mirror that's right here, and the camera's over here. The camera's looking at the mirror that's reflecting up. That's how you don't melt your cameras. You have them look literally through a periscope. A NASA idea, by the way. Alright, let's see. Old Saturn tech. Yep, dang right. There's the green flash. Pyrophoric ignition. Okay, there's your throttle up. And then send it. That looks okay. That looks okay, but then we lost it. The T-Rex sound, the honk, yeah. Mm-hmm. Yep. That's an overpressure event, Squall. The honking noise, that honk when the thing goes, overpressure. That's supposed to happen.
4,
3,
3,
2. That noise. Oh yeah. No, that's normal. Yep. Sounds like the T-Rex from Jurassic Park. Yeah, rocket engines do that. Hear this noise right here.
4, 3, 2, 1. 0, 1, 0, Zulu.
RC transition operation procedures to PRC MLP 1435. IT commits to PRC MLP 147.
Everything looks okay there. Yeah, that one's really hard to tell. It's really hard to tell what went wrong. I mean, it's one of the engines is having a bad day, I think. That would be my guess, but once again, that's not saying anything that anybody doesn't know. That's like you know, somebody getting, or like a car crashing or something. Like when they're doing a crash test, right? And a crash dummy like hits the wall and saying, "Huh, some metal crunched." It's like, yeah, some metal did crunch. Thanks for that one. The engine could be 1,000 different things because there's 1,000 different parts on that thing. They're complicated. Did we learn what that first abort call was? I never heard an abort call, dude.
2 seconds.
Here.
Stage 2 pressure.
Here, I'm gonna blow out your eardrums.
Here we
Let's
go. Good
let's
luck,
watch it again.
Firefly.
Let's
9,
see.
8, 7, 6, 5,
Good board.
4, 3.
I don't know what he said there.
0, 0, Zulu.
RC transition operation procedures to PRC MLP 1435.
You guys want me to go back even more? Okay. We'll scrub back. Let's see what we got. Let me listen.
Here we go. Coming up on T-minus 1 minute.
I'm not gonna
60
look.
seconds.
I'm gonna listen.
Oxic press started.
Okay.
Trench cams looking awfully condensed there.
To stop the count, operators please declare abort, abort, abort on CD1, and VC will abort the auto sequence.
Yeah, that's fine.
VC at T-minus 30 seconds, verify alpha transitions to autonomous.
Yep, those are routine calls, guys. Nothing to worry about.
30 seconds.
2 engine levels are at 2%.
You were talking about the first abort. Give me a T0, an MET, rocket guy. We'll listen. It sounded like someone said abort at like T-minus 3. It sounded like it, but I can't hear it. At 8 p.m. ET, their first window. I was talking about the first abort. Oh, okay. Let me go back and read. No, we didn't know. We don't know what that issue was.
20.
Just that little bit of gimbal there.
It was probably flight
15.
termination, Tylen. Underperforming rocket. It started doing this,
10.
Firefly.
9,
and then they just
8.
popped it.
7, 6, 5,
Good board.
4, 3, 2, 1. 0, 0, Zulu.
RC transition operation procedures to PRC MLP 1435. IT commits to PRC MLP 1457. Report anomalies.
Able? Yeah, something
Please
like
confirm I
that,
have
dude.
no
I
fires on
couldn't
the
hear
pad. I
it.
have no visual. Please confirm no fires on the pad. Moving to ground.
I'm looking. I'm about to send them all the pad sweep. Cameras are sweeping the pad.
Plus 32 seconds.
That certainly looks like what happened, Vulcan.
Drop call.
But it looks like it started doing this, and then it took a left and
Prop
it
is
blew it up.
nominal.
Oh my god, they're doing it.
GNC.
Sing a dip
Yes.
and VMAG.
Yeah, rocket guy, I'm with
There's
you.
no
Again, this
there's
is
no fires on the pad.
Avionics.
Responding
Reaver,
area.
Reaver, like Reaper, but with a V where the P is.
S1
Okay.
pressure profile nominal.
All right, guys, look. So they're calling stage 1 stage 1 tank pressures are nominal, but watch the clouds. The rocket's kind of doing this. Watch the clouds in the background here.
Okay.
See? That's a little bit of roll. A little bit of a correction.
S1 pressure
Back the
profile
other
anomaly.
way, another correction, and then the camera shuts off.
Avionics power.
So the thing's doing this. That could be a lot of things.
Telemetry is
There's a ton of things. That could be anything from propellant slosh to an underperforming
This is their
first stage.
first ever attempt at going.
Sometimes what happens is when the rocket's going up, you get a whirlpool inside of the tanks, and the propellant starts sloshing around. You get a phenomenon where the rocket will do this, or something like this, because they're literally the gyroscopic forces from the propellants swirling inside of the tank it'll cause the rocket. It'll impart force on the rocket. That actually does happen. That happened to SpaceX on one of their Falcon 1 flights. Second stage tank did this. It's kind of like a corkscrewing motion. So it's the thing's kind of doing this, and then it kind of goes back, and then it kind of goes back again. That could be propellant slosh. It could be an underperforming first stage engine. There's a bunch of there's like 1,000 different things that could be. This one's a little bit harder to call than the Astra one. The Astra one was pretty straightforward when the rocket went sideways off the pad. These guys got a little further though. Not harping on Astra. That was all this stuff is really complicated to do. Like anybody that's willing to throw their hat into the ring and try this has my respect. I saw it with my own eyes. The rocket hit max Q, started turning, went sideways, and boom. Also took a page out of your book for this. Does that mean it's not coming on then? Nice. Now, Lavi, watch the cast. It does this. The thing starts swirling around when it takes that turn that you're talking about, and then pfft. See last, trust you. I saw your last and have already replied to you before you typed see last into chat. Could be chat delay because you're on your phone though, so just bear with me here. Do not show Lavi's pics on stream. They said to contact them for licensing. Lavi is in the channel, Smirks.
Discovery,
She's here. Hey, Sing, 5 month. Or 5 subs, gifted 5 subs, not a 5-month resub, idiot. Yeah, no, that's who I'm talking with right now, Spurks. All right, Lavi, let's take a look. Let's see. Singularity, thank you for the subs. I really appreciate it. Yeah, see, Lavi, look. See, just you might be right. It did take a lefter into the wind. You're not wrong, but watch. It does like a swirl. See, it's doing this, and then takes a left, and oh! But look, this is consistent with a whoop-de-doo. Some type of oscillating motion that's making it do this. That's engine gimbal wouldn't do that unless the guidance system wasn't working correctly. Here, Levy, we'll take a look. Looked bigger from your viewpoint. All right, let's, where's your pictures? Let me take a look-see. All right, let's see. Let's see what we got. Oh, yeah, see this? Look at that swirly boy right there. Look at the flame. Kind of goes this way, and then it goes back, and they were like, nah, never mind. Never mind. We'll try again later. Ooh. Yeah, look, there's your payload. There's the payload coming out the top on fire. Yep. Yeah, Levy, it definitely took a left. But see, look, it's going here, and then it goes up, and then it goes that way, and it's like, no. Nah, never mind. Never mind, I got an idea. Hey, yeah, silly. Yeah, that's right. If they did lose an engine, they could have some real problems there with. You could have some real problems. Payload kept going on for ages. We saw it trail for like 2 minutes. Oh no. Yeah. Oh jeez. Oh, I mean, it's. Hey, whatever, man. Send it. Put another one on the pad. Send it again. Oh, there goes the payload. Oh no. But see how the flame. See what the flame's doing? Yep. Hold on, I'm gonna try something. Good pictures, Levy. Very nice. The payload's like, I can do it! I can do it, I swear! Hell he did say send it again. Well, they should do that again. That is not how you nitrous boost a rocket. Looks like we're blasting off again. But the dynamics from the fluid on the vehicle based on the specific implemented design will always be different unless designs and operating conditions are exact. Yep. Did the payload make it to orbit? No. Yeah, see, actually, you know, fellas, I'm not even 100% sure that this is, and people are probably going to be like, no, that's not right, EJ. People, so, Lavi, this picture shows a lot of unburnt liquid oxygen there. That might not be the detonation system. It could have been shear forces because of whatever's going on there. Sorry, that was meant to another chat member. Yeah. No worries. All right, Baldasaur. Thank you for watching, man. So, I mean, guys, that could be slosh. It could be propellant slosh. It could be an underperforming engine. There is a ton of different things that could be. It could be an engine. It could be engine TVC. The thrust vector controller on an engine could have broken. And if one of those goes out, that means you only have one of them for your roll. So that would explain the roll overcompensation. Which, I mean, but that, dude, it could be 1,000 different things. Well, yeah, you can tell because the rocket went this way and then it went sideways and it ripped it in half. That's what aerodynamics will do at hypersonic. Well, not hypersonic. Not even hypersonic. Supersonic. They just had called supersonic. They were way behind schedule, so it seems an underperforming engine could be a lead candidate. But yeah, Trojan, that's what I was saying. Underperforming engines can come from propellant slosh. If literally, so you ever like with your kids, dude, you take 2 bottles, you put them together, and you watch the water swirl around. If that happens inside of the tank, you're gonna have a bad day. That can cause all kinds of bad stuff. You could get cavitation in the propellant lines going to the engines, and then your engines underperform because they're not engineing correctly. Remember what I said? Well, Trojan, I don't know if you were here for that, but remember what I said like before we were launching? It's a liquid oxygen and kerosene engine. If anything's going into your propellant lines that isn't liquid fuel, or that isn't liquid oxygen and kerosene, you're going to have a bad day. So maybe the COPV not pushing helium through the tanks fast enough. It could be. Starship had cavitation in the lines. Exactly. SN8 had that problem. Rocket guy, I don't know, man. You think slosh? What do you think? I mean, it's obviously way too early to tell, and we don't have the flight data. We're not Firefly, you know. So it's hard to say. I saw for a slight second the entire thing sideways before it's snapping in half. Aerodynamics is a B. Sorry for bugging you with this picture, but go back and look. The engine was trying to start. I was not consistent. It's too hard to tell, Flykin. I don't know. That could just be artifacting on the camera. It's too hard to tell. I saw it. But yeah, it could just be the sunlight, dude. That camera angle is kind of poop. If I had multiple angles of all the engines, then I'd be able to show you. Then we'd be able to look. Engine out. Let me take a look at Jack's picture here. These photos are coming from Jack Beyer over at NASA Spaceflight. Let's take a look. Yep, see, once again, when your rocket is doing an S-turn, that's not good. Yeah, that's true. Yeah. DOS works for NSF, he's the producer. I don't know, honestly. Thrust issues seem prevalent. Lack of acceleration, and then off-course control, though acceleration did look good off the pad. Yeah, Rocket Guy, that's why I'm kind of holding on to that propellant sloshing thing. Because if it left the pad and everything, I mean, everything did look right leaving the pad, your propellant isn't sloshing. So, I mean, I don't know. It could be that. Could be wrong. Yeah, you definitely got some underperformance after it left the pad, for sure. Heck, a freaking fuel line could have broken. We don't know. We saw stuff spraying off the side on the cast. Like, dudes, if we go back over here, right, and we look at the onboard, you're seeing all kinds of stuff come off the side over there. They could have broken a LOX line. If a LOX line is broken and it's spraying liquid oxygen out the side of the rocket, yeah, you're going to have a little bit of a bad day. Yeah, everything looked okay. That looked right, dudes. Can we play liftoff one more? The engine's gimbaled aggressively. That's the it's the TVCs turning on, dude. The thrust vector actuators only work when the engine is on some rockets. On some rockets. So they could be using RP1 for hydraulic fluid in an open loop cycle. So the thrust vector controllers could be using kerosene, right, to steer the engine, and then that kerosene dumps into the rocket engine. They could be doing that. Soyuz does that, if I'm remembering correctly. They perform a wiggle test right before ignition. Okay. I think sloshing would show more oscillation before engine underperformance, but that's just as much speculation. Rocket Guy, I'll defer to your judgment, to be honest with you. Oh, yeah. Yep. Okay. It's a closed-loop hydraulic system. The engine's gimbaled. Watch the motors. See that? Yep. It's a closed-loop hydraulic. Watch the nozzle. It's quick. You don't see it very fast. Yep, see?
Discovery, go at throttle up.
See? Yep. Hey, Airborne 36-month resub. Video from Jock! Okay, Mr. Starship Update, what do you got for me? Alright, let's see. Oh! Okay, yep, Lavi, yep. That was epic. Oh, God. That's nuts. Oh, no. Deja vu. I just been to this place before. Higher on the beat. VTech just kicked in, yo. Yep, the range guy said no. Okay, Levy, yeah. That definitely was not no, it turned. Yeah, you were not wrong. Yep. Yep. Oh. Come on, it's trying. Oh, jeez. Oh, man. That's not what it should be. Oh, my goodness. Yep. Astro would have let it correct and had it keep going. Yeah, okay, so let's see. So, yep, right there, that pop right there, that's aerodynamic shear. So, yeah, what Lavi said was correct. So, what you're seeing come off the vehicle there is the payload fairing. Yeah, you're seeing the payload fairing just sheared off. Because you can clearly see the liquid oxygen tank, RP1 tank, interstage, stage 1 LOX tank right there. Yeah, that piece that just came off was that payload fairing. Yeah, see, there it goes. Yeah, it obliterated itself. And these are pieces of the payload flying around. So now the rocket has no payload. Yep, that's flight termination system all day. Link, please. This is coming. So this link is coming from Jack Beyer here over at NASA Spaceflight. What a shot! Straight out of KSP, dude. It looks just like it, man. Life imitates art. PUFED off nominal. Hey, Shaw, 74-month resub. Thank you. I'm impressed the tankage could take that much shear load. Yeah, for sure, man. Not many rockets can do a drifto like that and survive. Oh! All right. You know, it's not funny, but I know Firefly will be back, so it's like when we were watching the SSTO blow up this afternoon. It's like, it sucks, but it is kind of funny. What a monster. Pizza King, 16-month resub. Thanks, man. Yeah, so that's the payload fairing that just exploded. Aerodynamic forces obliterated the payload fairing. See how it's in a bunch of different pieces? And there's bits of your payload flying off right there. Yeah. Oh. Look through my photos after Byers post sideways. No, you were right. That was correct. Yep. Yeah. Yeah. Sheer obliterated the payload fairing right there, Lavi, and then I think they terminated it. But holy crap. That's ridiculous. Yeah, wait, let me hear it pause. Send it! Oh, God! Oh! Oh! Yeah, the photographers are like, oh, go! So what happens to the company that paid for the payload? It was a test flight unstoppable. It was an internal payload. Or actually, no, it wasn't, if I'm remembering. Let me go back to the press kit. This had a bunch of small... it has a bunch of small things in it. There was a commercial payload benchmark space systems, okay. Yeah, there was a couple of different payloads. Test article for Firefly, they had a Hall effect thruster on board. And a couple of satellites from a Greek non-profit called the Libre Space Foundation. And there was a postal cover flown on the Mir space station. Ooh. Whoops. Ooh. Yeah. All those things that I just mentioned are coming off of the vehicle right there. Yeah, see these little things? Those are all the little things. Off to the thingy right there. Keyword was. Yeah. Yeah, that didn't really work. So there's some peculiar outgassing coming from when the rocket is completely sideways. See that right there? Something's breaking right there. I don't know what it is. That looks like liquid oxygen coming off of it. It could just be the contrail though, but it definitely, yeah. Look at that. Looks like LOX. Oh, that's gnarly, dude. This is a contrail. The rocket exhaust is hot. The atmosphere up there, the temperature is really low, so the gases... Yeah, they produce the contrail right there. They condense again. Oh! Yep. Flight termination. See the simultaneous explosions? That's FTS. That's a flight termination. The range coordinator said, nah, never mind. Maybe, Jaka. I don't know. As it goes sideways, watch the engine exhaust. One looks really way shorter. Yeah. Consistent with engine underperformance, the plumes are 2 different sizes. Was this better than Falcon 1? It got further than Falcon 1 on the first flight, silly, yeah. It got further. Guys, you know what? I think there's a LOX leak. Like, now that I'm looking at this, watch right here. Watch that puff of smoke. Shh. You see that? They could have ruptured a LOX line. Who knows? Yeah, Smuck, pretty much. I mean, I've never seen a rocket drift you like this. Oh my. That's nuts. Yeah, it's definitely not Contra. Can I just watch it again? That's awesome. It's so cool. I don't care if it failed. That's cool, man. It's trying. It wants to go so much. Oh, it was trying. Hard to call casual after the flight anomaly, as those sudden loads should cause so many cascading failures. Yeah, that's true. Yep. Yeah, basically the thing wasn't designed to fly that way, so that could be a result of it. This thing right here could be a result of it drifting. Yeah, that's right. Oh, this footage from Jack is legendary, man. Yeah, so, Levy, this is what you were talking about. I couldn't see this from the webcast, so I wasn't sure. So I'm like, I don't know, maybe. But no, it turned sideways. Yeah, no, that definitely popped. Ian, all in all, this seems like a good first flight. They got 2.5 minutes and Pat is completely unharmed. Yeah. Freaking ridiculous, man. As long as nobody got hurt, it's fun to watch. Who told me to see their last? But what happened if a company paid for the satellite? Insurance happens. Unstoppable. Yeah. On the mainstreams, it appears the lock started leaking between 1 minute and 125. Yeah, Stone. It looks like it's popping off the left side, but I don't know. Rocket is like, wait, I don't want to go to space. Fine, okay. Devious, what was your last? Did I get it? I'm trying to scroll through. I think the fairing hit the engine. See the flame right before the fairing debris. It's possible that something came off and hit it. Yeah. Oof. Yeah, that's the fairing popping right there. We gotta thank Tim for letting us see this. Yeah, thank Tim, thank Firefly. Firefly gave no fricks. They streamed the whole thing. They're like, yeah, well, whatever. They even streamed the countdown loops, guys. I mean, once again, I don't mean to echo Tim's words, but not everybody does that. Not everybody has the balls to do that. It takes guts streaming your first launch. It takes guts streaming your first launch with your countdown loops open. So listening to what the people are saying when they're going to launch the rocket. It takes balls. Payload survive then? If it's a submarine, then sure. No, yeah, Core. Yeah, I was still playing KSP. That's cool. Link? And instead of saying go, they said send it. COPVs always look like that. Yeah, that's right. So is it coming on? That means it's not coming on then. Yeah. Pretty crazy, dudes. The payload is guaranteed to be in at least 2 places. But see, the problem is, Crash, is those 2 places that it could be is not where they wanted it to be. That is, you know, the payload has acquired a deviation and its variation. It could be corrected by the GEA. The payload knows where it is. It knows this because it knows where it isn't. Pieces, not places. Yeah, you know, I like it my way better. Thank you, but I like it better my way. Yeah. Hey, good first attempt. Yeah, John. Yeah, go to sleep. We're gonna shut it down here. I mean, it's the payload still exists, but it exists as an idea. But anyway, it takes balls to show this, especially showing up the business end on the first launch. Not even SpaceX did that. No way. Its location is known. It's in the Pacific Ocean. Yeah, you're not wrong. So what's tomorrow's plan for plan blast for KSP. We got to finish cleaning up the museum area and get the pad out there and get the small SSTO up and running. Needs to be operational again. We going all day KSP tomorrow though. Need to know now so I'm here on time. Yeah, we could do it. I wanted to keep going in Starbase, but that's fine. We can keep going in KSP. That's fine. Hey, Simba. Hey, thanks, man. Thanks for watching, everybody. They didn't synchronize the panometric fam. Yep. Anyway, so I'll leave you with one last replay of the launch here. And, yeah.
Just that little bit of gimbal there.
Let's see. Let's just watch it one last time, and then we'll, then I'm going to head off, guys.
Here we go. Good luck,
10,
Firefly.
9, 8, 7, 6,
Hey,
5,
Minix, thanks for the raid.
4, 3, 2, 1, 0, 0, Zulu.
RC transition operation procedures to PRC NLP 1435, IT commits to PRC NLP 1457, report anomaly. Please confirm I have no fires on the pad. I have no visual. Please confirm no fires on the pad. Moving to ground.
I'm looking.
rain.
I'm about to send them all the pad sweep.
Yeah, pretty crazy. It got off the pad okay, but yeah, something went weird with the engines. But anyway, that's going to do it for me, guys. I hope you enjoyed that coverage. We've put in a lengthy 11-hour stream today. No big deal. Do the old American sign-off. We could get DMCA'd for that, but... yeah, we'll crash. If they called abort, that means they didn't do it right. Anyway, Lavi, thank you for the pictures. Guys, thank you for watching it with me. And be sure to thank Firefly. Show them some love. That was the first attempt. They got pretty far on their first attempt. That wasn't bad. Anyway, let's see who we can raid. What do you guys want to do? You guys want to watch RimWorld? Want to watch some drag racing? Murder's streaming some drag racing. You want to go watch that? Or we want... yeah? Yeah, let's go see what Murder's up to. Night, Gold Falcon. I'll talk to you later. Alright, let's go see what... let's go see what he's working on there. Ceremonial music is... yeah, let me look into it, guys, before I do it. We'll do it another night. Go see what Murder's up to.